Okay, so really quick, we're gonna go, first off, I'm gonna go to an actual rack, show you what's going on at the rack, and then we're gonna come back here, we're gonna discuss it all, okay? So I just want you to know, this is my opinion on how it works. Okay, I'm pretty sure I did quite a lot of research to try to make sure that this is as tight as I can get it and as an overview. But if you have any, things you want to add, nuances you want to talk about, please comment below. I really want to make this a place where people can learn and grow. And just remember, I'm just a dude on the internet. Double check everything I say. Check with your leads, check with your bosses, check with the manuals, obviously. And, we're going to slug through this and hopefully you'll learn something. So let's begin. Okay, so today we're going to learn about receivers, refrigerant level, and all kinds of stuff. And we're going to start off with this, this actual room. Well, this isn't a room, but we're going to start off with actually hands-on, looking at it. Then we're going to move to some pen and paper, and maybe back. We're going to do a little bit of that. Now, just disclaimer, I'm not a practicing engineer. Whatever. Just this is my opinion on how it works. Hopefully you'll learn something. Let's start. Obviously, we're just going to take a quick look. The discharge comes out of the compressor, goes to that discharge header over there. Okay. Discharge header comes up here. Actually, that's the liquid side. It actually is going to go down the other way. And it goes over there. All these, various pipings, right? So it comes up through your oil separator, hot gas differential valve, comes around. You got your hot water reclaim. So if hot water reclaim is activated, goes up hot water reclaim, goes out to hot water tanks, comes back. Now it's going to your condenser. So obviously we got condenser seasonal, condenser, supply always on, and now we're gonna go or split, full. Now we're gonna head up there and look at our condenser. I'm doing this because everything's obviously very important, how it all links together, and you'll see as I put it to words and whatever. But so here's the discharge, comes up, goes in the top of the condenser, condenses down to a liquid, comes out the bottom. Here's the liquid line now, drop leg of the condenser. As you see, it's coming down. This right here is a check valve. So if you look at refrigerant only flows this direction, can't go back up. From there, it's gonna go over to, now here's the important valve right there, that blue valve. That is an A8 valve, or also known as the holdback valve. So what this valve does is it holds back a certain amount of refrigerant or a certain amount of pressure in the condenser, right? So how much pressure does this hold back? This holds back around, just a rule of thumb, 110 PSI above your highest suction group. So if you're on a rack refrigeration system, you might have low temp and medium temp, and then you might even have a subcooler group, depending on whatever. So low temp, let's say 20 PSI, medium temp, let's say 50 PSI, and then subcooler, maybe 60 PSI, depending on how the system's run. So let's say if 60 PSI is your highest suction group, that means this is gonna be holding back a minimum of 170. And I'll explain how this works with the pen and paper. Typically only works for low ambient conditions. Now after here, you have your liquid line or drop leg going into the top of the receiver, okay? Now obviously you have your receiver gauge, and out of the bottom of your receiver, you have your liquid line coming out. The reason why it's coming out of the bottom is because, as we know just by physics, liquids are heavier than a gas, right? So that means the liquid will sink to the bottom of the receiver. So if you have it coming out of the bottom, you'll get a better quality of liquid coming out of there, going to your system. Now, we have these two other guys coming out of them. So one of them, if we look at and follow it, comes over here, goes up here, and goes back to this liquid line right here. Now, if we look at, there's a check valve for only one way. So what does that mean? Well, what is this doing? If this receiver happens to go to a pressure for some reason that is higher than your condenser, we can't have that, because then your condenser won't want to flow to your receiver. So if that ends up happening, this line will take, let's say somehow hot gas is getting in your receiver. I don't know how, just blowing into it, or maybe it's just in the sun like it is today. It's super hot out. Let's say now that receiver level's going up in pressure, it's super hot, right? The vapor will travel up through there, and so basically it'll pressurize above this liquid pressure. It'll push that excess refrigerant out and into your condenser, right, on this side of the liquid line, causing that liquid to kind of keep feeding into the receiver itself. So that's kind of if it happens to go over pressurized, hot sun, somehow hot gas gets in there, whatever the case. Now from there we have that last one that you can see is the far one in there. I can't really get to it, but if you follow it down, it'll go down here, and that's going to go back in your machine room, and we'll go take a look at that. So that pipe will obviously come down from the condenser, you know, wherever it goes, and we're going to follow it, and it's actually going to come all the way over here to the discharge side. So we're going to come over here, and we're going to see this valve right here. Now, even though this is going to sound silly, but this valve it says A8 on it. I've heard it called an A9 valve. So I don't know why, I just heard it called that. I'm going to just call it the receiver pressure regulator. So what this does is this regulates the receiver pressure. So this is set for 100 psi over your highest suction group. Okay? So that means if your highest suction group is 60, then that means that it's going to be set to 160 in the receiver. And so we're going to see this on the pen and paper. As you can see, this is just hooked right into the discharge. And that's actually allowing discharge gas to flow into the receiver. And so just to show you, just so you have a conceptual idea, those are suction groups. So right here is a suction group right here. This is a medium temp suction group. And if we look, there's actually a separation there. Now this is a low temp suction group right here. Now if we come over here, you can see there's another separation right there. And this is an even lower temp suction group. And they each have 3 distinct pressures. So those 3 compressors are working on one pressure. Those 3 compressors are working on another. And those 3 compressors are working on another. And so now what we're going to do is we're going to go to the pen and paper, and we're going to learn a little bit about the theory, why you set the valves the way you do, how it all works, how it flows, and then why do we never get like an exact refrigerant level on rack refrigeration. And I just want to touch upon this point before we go over to the pen and paper, is you can see right here that this rack, so the way that this would work is this rack will come prefabricated. This whole thing will be fabricated. You know, they'll probably, you know, either when this building is being made or if they're going to put it in, they'll actually have to take out doors or windows or the ceiling or something. And what they'll do is they'll swing in a whole new rack, and on that rack it'll come prefabricated with these hookup lines, right? So you can't actually give you a dedicated charge, because as the store grows and the customer clientele grows, they're going to eventually expand with those lines and install new cases. And sometimes they might even overload the capacity of the rack. Like they might put a whole nother header someplace or something. And so you can't just necessarily put down a fixed 800 pounds of refrigerant or, you know, 1,000 pounds of refrigerant stamp on the system, because the system capacity will vary over the life of the system. Because they might even, let's say right here, you know, we got a reach-in frozen case right there. They might take that out and replace it with something else that requires more or less BTUs based on the kind of product that they're selling. So anyway, we're going to go to the pen and paper and learn a little bit more. So just to kind of show you, as I mentioned, so that line comes up here. You'll see it kind of come up there, through there, and into the receiver. So that slowly feeds hot gas into the receiver to keep it at a certain pressure, and we'll go over that now. Okay, so really quick, so now that we just went through that whole valve and everything in the receiver, we're just going to go through. So obviously you need to be somewhat acquainted with the refrigeration cycle, but so we're just going to go through this. So first off,
you have your compressors, 1, 2, 3, 4, 5, 6, 7, 8, 9. And all those compressors are attached to certain suction groups. So, for instance, this suction group is 10 psi, this suction group is 16 psi, and this suction group is 46 psi. That equates to a 22.6 degree coil, a negative 10 degree coil, and a negative 20 degree coil for R22. Okay, I just want to lay out the lay of the land. So we're going to follow the discharge up here. So let's say we're targeting 180, right? We're going to follow it up here, right? And then out of your discharge, kind of like we saw in the video, we'll have our RPR, our receiver pressure regulator, or A9 valve is what I've heard it called. And then up here we'll have our split valve. Okay, so from there we'll have our condensers, and from our condensers we'll have them join up, and we'll have our holdback valve to our receiver. Okay, so when we're targeting 180, okay, so if we look at our holdback valve, as I mentioned in the video, the holdback valve has to hold back a minimum of 110 above the highest suction group. So if we look at our suction group, the highest suction group is 46. So this holdback valve has to hold back a minimum of 156 psi minimum. Okay, so when we're targeting, let's say our Danfoss controller, Emerson controller, whatever controls your system, is targeting 180 psi, this valve isn't doing anything. It's not doing a single thing. Okay, what is controlling that is your actual controller and its compressor cycling. That's what's controlling it, is how often it turns on your compressors and the fan cycling for the condensers. Okay, so it'll choose to turn on more fans, which will lower the temperature, which will lower the pressure. Okay, or it'll choose to turn on less fans, which will raise the temperature, which will raise the pressure. Okay, they try to target this corresponding pressure there. Okay, so this holdback valve isn't doing anything. Also, at this pressure, okay, a lot of the time, if I go to the receiver, you're only going to have a pressure like this when it's warm enough to do so, and a lot of the times the receiver pressure regulator isn't really doing anything either in the temperature that is warm enough to actually hit this target pressure. So let's say we're at 70 degrees or whatever, right, and we have our receiver. Okay, our receiver is going to be around 70 degrees. Okay, and so what's going to happen is we're actually going to have this refrigerant inside your receiver kind of boil off naturally, and that's actually going to kind of pressurize the receiver to kind of already be 100 above the suction group, more than likely in a weather that's like 70 degrees or 90 or whatever it is. A lot of the times this receiver pressure regulator isn't even doing anything either during that time. Okay, so when does this receiver pressure regulator and the A8 valve actually do anything? Well, when it actually does something is during the winter time. So when it's like 0 degrees out, negative 10 out, right? When this receiver is at negative 10, that might correspond to a pressure of, if we look over here, negative 10, 16 psi, right? Well, in order for our TXVs to work and to feed refrigerant properly, this is just a rule of thumb, you need about 100 psi of difference between your liquid line and then what your evap coil is. Okay, so if we look at this 46 psi, if this is 16 psi, this isn't going to work, right? And so the reason why this A8 valve is 110 above is because this receiver needs to be 100 above, right? So what happens is this A8 valve, let's say we're in a cold winter climate, negative 10 degrees, right? This A8 valve will hold back refrigerant, right? So it'll make like a little orifice that allows refrigerant to go through slower, okay? And that will cause this condenser will also shut down one of these condensers during the winter as well. And it will cause this condenser to fill up with refrigerant, right? And what that will do is that will cause this gas to be in a smaller volume, which will cause it to have a higher pressure, okay? And not only that, but it'll shut off all the fans so it stays warmer as well. So it will meet this 156 minimum requirement, and that's when this valve starts to work, is when this condenser is under that. When it's under this 156, this valve is going to go, oh my gosh, can't have that happen. It's going to hold back refrigerant, cause refrigerant to fill up this condenser, and thus smushing this volume here. So we're going to have more volume of gas in a smaller space. I mean, more gas in a smaller volume, which is going to increase the pressure. Okay, so this is going to be 156 at a minimum during this cold weather condition. Now this receiver needs to be 100 above the highest suction group in order to feed the refrigerant out of the receiver. So you can think of this like an aerosol can, right? So you have this liquid refrigerant in the bottom and you have this gas on top. So what this does is this valve over here, the receiver pressure regulator, will go, oh my gosh, this is not 100 above suction. This is just not. So what it'll do is it will release this hot gas into this top half of the receiver, and what this will do is it will pressurize this liquid that's in the bottom, right? And now your A8 valve is causing this to be 10 psi above this, so this refrigerant will still flow into your receiver, and now your receiver is 100 psi above your highest suction group, so it'll push the refrigerant out like kind of like an aerosol can, and then it'll feed it to the TXV. So I just wanted to show you because I thought it was a good illustration for like a receiver and how the gas works. So this is, you know, just a normal like aerosol type can. You know, I took it from home. You know, it sprays out oil, right? So it comes with its own pump right there. So you can see you put that on there, and all it does is it pumps in air and pressurizes above the oil. So this part of it is air and the lower half is oil. Just like the A9 valve is doing to the receiver, is it's pressurizing that top portion with hot gas, which will cause the receiver to feed to the TXVs. And actually, even the spraying action is actually not a bad representation of what the TXVs are actually doing. Is they're metering the flow down and slowly releasing it to the coil. So I thought that was worth showing as kind of a demonstration of a receiver and how the gas is working to push it out of the receiver. So these two valves are mainly for like cold weather applications. And so obviously this one is 156 because it's 100 plus 46. That's what this one will be set to. And this one will be set to 156 because it's 110 plus 46. So this is 10 psi higher than over here. High pressure flows to low pressure, which will then flow to your TXV, because on the other side of your TXV is low pressure, and that will flow back to your compressor. Okay, so now this last thing that we can look at is this check valve that we saw from it right there. So if this does happen to go higher in pressure than this condenser, okay, for whatever reason, whether it's cooking in the sun or you know, maybe it feeds in too much gas with this receiver pressure regulator, or it suddenly gets a cold spell and these condensers drop down and this valve can't adjust it enough, or there's not enough refrigerant in the system or something like that. What will happen is this will actually blow the refrigerant. It'll send this hot gas or refrigerant or whatever it is through here, through this check valve, and put it back into the condenser, and then it'll kind of flow back down. I've seen this actually piped over here to the discharge. I kind of think it's a better setup for it, but the one that we saw was piped into the liquid side. It could also be an overfill too, if for some reason this filled up too much, like somebody overcharged the system, it could dump the extra liquid into the condenser so it doesn't, you know, blow out the receiver or something. Now that we kind of have a concept, a general idea of how a receiver works and the valving that causes the receiver to work, what we're going to do is we're going to look at this receiver level. So some of you guys might have heard the rule of thumb, or it's again a rule of thumb, refer to your manufacturer or whatever specs you have on your rack system, of 20%. Okay, 20% receiver. What does that mean? Well, your receiver is constantly feeding to your system right, the whole time. So it means that at normal operating conditions, which let's say normal operating conditions could be 70 degrees in your store, 70 degrees outside, 50% humidity. Okay, you should have about 20% in your receiver. Okay, and so it has this constant flow that's always going around, and you're gonna have this 20% in your receiver. So if you go to a store and you're like, okay, I need to charge it, 20% is everything's at temp, everything's at the right temperature, okay, and this just kind of your normal load feed rate that is kind of going through your system. You should have about 20% in your receiver. That's how I'm defining it. Your manual might define it different. It might mean that you need it manually on every single case in order to have your proper 20%. Now during the winter time, you might hear this 80% during the winter. What will happen is one of these condensers will shut down, and it will pump all the refrigerant into your receiver, and so your receiver level will actually raise up more during the winter because one of your condensers is down. And then not only that, but you're gonna have less refrigerant flowing through your system because one, your store is gonna be colder, so it needs to work not as hard. Two, your condenser doesn't need to work as much because now it can take the heat from your refrigerant easier in the colder weather conditions. So you're gonna be flowing less refrigerant around. So I'm going to kind of show you an example of that now. So I just wanted to show you this demonstration. So if you look at, there's varying size holes in these bottles. It's a little bit messy around here, so ignore the mess, right? So if you think of like a receiver, right? So you have your compressors going, that's putting in a certain amount of liquid refrigerant into your receiver, right? And that liquid is draining out at a certain amount during a certain, condition, for instance, summertime or wintertime, right? And so your receiver will naturally kind of equalize at, let's say 20% or whatever based on your load. And then, as the compressor cycles, so some compressors might shut off, and now you're going to get, less refrigerant flowing, right? And then, it might drain out a little bit, and then now it turns on based on the suction pressure. And now it's, coming out a little bit more, right? And now let's say, you're during the winter season, and now you're going to have, if you look at hardly anything coming out, and that receiver is going to fill up way faster with refrigerant. And so you might have a receiver that's, let's say 80% or something like that, and it's just slowly trickling out right there. And now during the summertime, the last example is this, open bottom bottle, where you can see that it's just going right out like crazy. You'll actually have a receiver level sometimes of 5%, a 0, or sometimes it might even appear like it's flashing because there's just so much refrigerant rotating through the system. So I hope that's a good kind of metaphor for what's going on. Anyway, so I hope you learned something with this. So we learned about an A8 valve or a holdback valve, 110 psi above your highest suction, our receiver pressure regulator or A9 valve, 100 above your suction, and we learn about your receiver and how it's kind of like managed. It's kind of like an aerosol can, okay? And if you're kind of wondering, so the reason why the piping comes out of the bottom is because naturally liquid is heavier than gas, so it kind of floats to the bottom naturally, and it helps feed the refrigerant out. But anyway, hopefully you learned something. Please like, subscribe, all that good stuff. Comment below if you have anything else that you want to share or whatever. Have a good one, and that's how you do it.